When the piston reaches the apex and opens the valve, you have a maximum pressure, but because the connecting rod is basically vertical, almost no force is being transferred to the crank. As the piston is pushed down and the gas expands, we get a better angle to transfer the force, but now the gas has expanded, so you don't have as much pressure and thus not as much force to be transferred.
I was thinking about what would be a better option than the piston crankshaft mechanism, and the first thing that popped into mind was, why not just drop the engine altogether and just drill a hole in the cap of the bottles and propel the entire thing like a rocket?
So, I put two soda bottles together and I 3D printed some nozzles. Then I built this test stand here, which is basically just a lever connected to a scale. If I push here, it gives me a value of force in the form of grams here. For the air to last more than a minute, I had to use a nozzle with a diameter of 0.8 millimeters, which is super tiny. But at peak pressure, the nozzle only produces about 50 grams of thrust, which is a fraction of what Tom is doing with this engine-propeller combo. To trick the laws of physics, I placed my nozzle at the end of a long bar to get more torque. Basically, I built one of those turbines the Greeks invented like 3,000 years ago. And after some testing and post-failure math, I realized I would need a 1 meter long bar for me to have enough torque.
Yeah, I don't think I'm getting away with rockets and turbines this time. I think I'm gonna have to actually design an engine.